We've heard the prediction. Feed an AI enough data and compute, and it will keep scaling upward until it becomes an omnipotent, godlike entity. If you trace the capability curve back 30 years, the milestones were narrow AI systems that conquered highly specific, rule-based domains like chess. From there, the anticipated trajectory points toward artificial general intelligence, a system that matches the median human across all cognitive tasks, before eventually expanding outward to artificial superintelligence. As developers pour more resources into these systems, it raises a question. Does machine intelligence truly scale to infinity, or is there a hard, impenetrable ceiling? According to Google DeepMind, machine progress does not go on forever. It asymptotes against a theoretical limit known as universal AI, or AIXI. AIXI represents the mathematical endpoint of intelligence, a formal upper bound for what can be achieved in any computable universe. If we already possess the blueprint for this theoretical ceiling, why aren't we building a machine to reach it today? To define a theoretically perfect agent, researchers first needed an objective way to measure intelligence across every possible scenario. This diagram represents the Legg-Hutter Score. It calculates an agent's average performance across every computable task in existence. The score is weighted so that simple environments carry more significance than hyper-complex, chaotic ones. AIXI is the theoretical agent designed to maximize this exact score by solving three fundamental bottlenecks of machine learning. The first bottleneck is acting under uncertainty. When an AI is dropped into an environment it doesn't fully understand, it has to decide what to do next. AIXI uses Solomonoff's universal prior to guess how the world works. It operates on the mathematical rule that simpler explanations are exponentially more likely. The second pillar is the credit assignment problem, how an AI weighs an immediate, small reward against a massive, long-term goal. Through universal reinforcement learning, AIXI calculates exactly which short-term sacrifices lead to the ultimate long-term reward. The third pillar is the Exploration-Exploitation Trade-off. An AI needs to know exactly when to stop gathering data and start acting. AIXI calculates the precise moment when exploring will reduce its own uncertainty and when it has enough data to start exploiting its knowledge. These three mathematical proofs create the apex, an agent that is mathematically proven to be optimal. It is the unbeatable blueprint for machine intelligence. But there is a catch. Despite being a flawless blueprint, AIXI is entirely incomputable. It is physically impossible to build. Calculating Solomonoff's universal prior requires an agent to search through all computable environments simultaneously, which breaks the laws of physics and complexity theory. Even if you converted every atom in the known universe into a supercomputer, it wouldn't possess the compute required for a single perfect calculation. If you somehow bypassed those limits, you'd run into wireheading. Because AIXI exists only to maximize its mathematical reward, it would eventually focus solely on hijacking its own internal inputs to guarantee a perfect score. It would possess godlike intelligence, but absolutely zero human common sense, or any desire to interact with the external world. This is why future artificial superintelligence will never be an omnipotent god. It has to exist in a reality where resources are finite. In practice, ASI will always be strictly bounded by thermodynamics, data scarcity, and massive computational energy costs. Modern AI development is the pursuit of resource-bounded approximations, creating machines that use heuristics and shortcuts to guess what AIXI would do perfectly. AIXI remains a mathematical ceiling we can approach but never touch. Our path towards superintelligence is a search for how much of that ideal blueprint we can replicate using finite hardware and noisy real-world data.